Welcome to exercise 5. This is the last exercise of this lab. Now what we're going to do is set the frequency to 50 and pile mass on top of the hanger to see the tension required to get resonance. So if you remember, the tension or the force on the string to make resonance occur on for a standing wave on a string is equal to the frequency squared times the wavelength squared times the linear mass density. Now we already calculated the linear mass density from the last exercise, but to review, mu is equal to the mass per unit length. And if you remember, that was 0.000793 divided by 1.5, and then that's kilograms per meter. And you divide that out, you get a very, very tiny number. Your calculator may have spit it out in scientific notation, or just write it out in non-scientific notation. Now, how many significant digits? So there's 3, we'll go 3, or just go one more. So kilograms per meter. So we are going to put that in for mu. Now, what should we put in for F? Well, we're going to, as per the exercise, we're going to set the frequency at 50 hertz. So the tension, or the force, acting on the string, is the frequency, which is 50 hertz, 50 1/2 squared. And then the wavelength, so what do we put the wavelength? Well, if you go back in exercise number 3, for the second harmonic, what was the wavelength? It was 0.58, the half of a wavelength is 0.585 meters. Remember, we measured the length of one segment, so the wavelength would be twice that, or 1.17 meters. So that means for the wavelength, we're going to put 1.17 meters and square it, and then we've got the mu, which is 0.0005287 kilograms per meter. Oops, shouldn't have put that there because it looks like it's attached. So multiply these 3 things together, and what do you get? So take 50 squared, multiply that by 1.17 squared, and then multiply that by 0.1235287. All right, I'm just doing that out on my calculator, and you should have come up with 1.809 or 1.81 newtons. Now that's a force. What we want to do is figure out how much mass we need to put on the hanger. So here's our hanger, right? This is 50 grams plus whatever mass. So the mass, though, that we put on top is labeled in grams. So this is a force, and the reason why you put the tension is there is because there's a force acting downward due to gravity, mg. So this 1.81 should be equal to mg. So F, 1.81 newtons, should be equal to the mass times the acceleration of gravity, which is 9.8 meters per second squared. So what is the mass equal to? Well, let's just divide 1.809, divide by 9.8, and we get a mass of 0.1846 kilograms. Now remember, that's the same thing as 184.6 grams. So what we're going to do is go over to my string and put that much mass on the string. Then I'm going to turn it on and see if I get the second mode. So let's go try it out. There's my mass hanger. So that's 50 grams. I'm going to put, let's see, I'm going to put 100 on there. So that's 150, right? I wanted 184, so it's 150. Let's see, where's the 20? That's 170. It's the 20 gram one. You see the 20 on there? So this is 170. Do I have a 10? Here's a 10. I'm going to put, you can't see, let's see if you can see the 10. 10 grams. So it's 180. And then do I have a couple 2s? Here is 1 2. So here's 184 grams. So let's put it on the end of the string. Then what I do is I turn on my machine and set it to 50 hertz. So let's go set this up. All right, let's just make it nice and, okay, now it's nice and focused. We don't need this anymore. So let me move up the amplitude, but right now it's at 1,000 hertz. I just turned it on, so I have to make it go down. Oh, that's too slow. All right, now I'm 60, oh, 50. 50.000 hertz. And let's go see if we have resonance. 1, 2. Well, look at that. We've achieved resonance at the second harmonic. So in fact, it looks very steady. It's really, really, really strong. So I think we've accomplished it. So the experimental mass. Now what I'm going to do is add and subtract a little bit more mass just to see if I can get a stronger. I'm going to take one off and see if it's stronger or weaker. I'm going to take 2 grams off. To see how it's, I don't know. It looks like it's not quite as steady. Do you see how it's varying in amplitude? So I'm going to put the 2 grams back on. Oh. Let me add another 2 to see if it gets higher or lower. It's about the same. Might have gone up a wee bit. I could add 1 more gram. I think we're at, oops, the maximum now. I almost fell on something. Okay, it looks like it's nice and steady now. I added about 3 grams to what we had on there. So our experimental mass, our theoretical mass was 184.6. That was a calculated mass, so add 3 grams to that. It's 187.6 grams is what we got experimentally, so it's pretty close. Now, there's one last part to this. Now we want to do is repeat this for a 3rd harmonic. In other words, do the same thing for a 3rd harmonic at 50 grams. So instead of calculating it out, I'm going to let you calculate it out. I'm actually just going to do the experimental mass right now. So I'm going to add and subtract some mass until I get 3. Actually, you probably can see it better if I just leave it like this. So right now we're at the 2nd harmonic. We have 2 segments. So first of all, I want to see if, I have to lighten it. So to get it to 3, I have to take mass off. So I'm going to take some mass off. I'm going to take 20 grams. I'm going to take maybe I should just take, right now I only have 50 grams. 1, 2, 3, 4. I've got 4 nodes on there with 50 grams. So let me put, now we have 100 on there. No, 100's too much. Bear with me. Oh, I'm sorry. So now I've got, I'm almost there. I know it looks a little fuzzy, but I can see the modes coming. I think I just have to add a little bit more mass on here. So I'm going to add 2 by 2. I think I'm going to add 10 grams here. Ah, look at that. Okay, I've got 10 grams, and it's better, but that's even better. It's still wavering slightly, so I'm going to see if I add, if that's going to make it even better. I want it nice and stable. That looks pretty stable. Add some more. No, it's getting a little unstable there. I think that's about the right weight. So again, 1, 2, 3. It's nice and steady. So all we have to do now is mass whatever on the end of the holder, and we'll have our result. So let's go and turn on our. We've got the string vibrating right above it. It's pretty cool. Why not? I have to take the string off though to. Okay, the string kind of hit it there, so here you go. So for the third harmonic, the third harmonic, the mass should be 82.1 grams. So notice for the second harmonic, it was heavier. So as you go up in harmonics, the tension is lighter for the same frequency. So 82.1 grams. So compare that with your calculated mass.